Yeah, so I'll be sharing some thoughts about API development. I'll compare some approaches, and by the end, I hope you get something to try at home. Yeah, so let me introduce myself. My name is Enis Spahi. I work as a consultant at OpenValue Munich chapter, and being at OpenValue Düsseldorf feels like home. So I'm happy to be here. So what we do at OpenValue is helping our clients to build better software, become faster. Meanwhile, we also like to share knowledge, visit conferences, and most important, have some fun. Yeah, and by the end of the talk, if you want to stay in touch with me, I'm sharing my contact information. You don't need to take any photo during the presentation because I will be sharing the slides as well. So we could start with the definition. So APIs, according to the definition in Wikipedia, are about application programming interfaces that enable two or more computer programs to communicate with each other. So they kind of refer machine-to-machine communication, right? So you have a server, you have a client, you have a piece of software running on both sides. They exchange over the network. And this is the machine-to-machine communication. But today I'll talk more about humans. And humans is important because we have two peers, right? A provider which builds the API and a consumer which consumes or uses the API. And if communication works fine, the mood strikes, everything works out fine, then you have two happy faces happily communicating with each other. But sometimes, depending on the boundaries, on the challenges, there might be some issues, right? So the picture might rather be like that. And yeah, let's try to see if we can make things better. So why it is challenging? Because we have boundaries, right? So we might be building an API which is used inside our organization. These are private APIs. In this case, two developers, provider or consumer, might be within the same organization, maybe sitting next to each other, maybe sitting on these remote offices, maybe communication would work well, but depending on the complexity of the organization, it might get challenging. Then you have partner-facing APIs. So if you are, for example, a payment service provider, you are providing your API to your business partners. In that case, the provider and the consumer might not communicate directly. The communication might be mediated from some other people, which maybe don't have technical knowledge. So in that case, you might need to have better documentation and things like that. Then public APIs are the kind of the APIs that run on the internet. So you have, for example, geolocation services, nowadays the large language models, which are consumed over the internet. And in that case, you don't even have communication. You have all the self-service onboarding, automation, and so on. And then you can't have one provider answer the questions of all consumers. So you really need to scale the communication. And then I would like to share an interesting survey which shows, this is by Postman, State of the API Report, published in 2023. It shows some obstacles when consuming the APIs, right? So on top, it is lack of documentation, right? So more than 50% of the API consumers are facing challenges because of lack of documentation. And then there are things like difficulty in discovering APIs, so they don't understand what are the API functions, the endpoints, connectivity, and so on. And then lack of time. So maybe with the lack of documentation, they are trying to compensate things by talking to each other, but they are not available for each other. And then lack of knowledge, maybe they try to discover things by checking the code and so on, which is not the best idea. These are the things on paper, but let's go a bit hands-on and see in first place while building an API if we can observe some challenges and make them better, right? So I picked a use case which applies to my daily challenge, and that is what should I cook for dinner? So me and my wife work long hours. When we are back from work, after a long day dealing with happy developers and so on, we have this challenge. So what should we cook, right? And we spend time, researching, search for a recipe, does it work, and so on. So my wife said, you are a consultant, solve this issue, right? And I said, okay, let me try to solve. So maybe we could have an application. There you could have a nice user experience, right? So you would put some criteria, let's say a title of a food, maybe add some ingredients to consume ingredients. I don't know. You would have some nutrition facts, like low calorie, high protein, and so on, depending on how you spent your day, if you went if you did sport, if you ate a lot, and so on. And then, as a result, you would press the search button, and you would get a result which shows the ingredients and instructions how to cook the food, right? And yeah, sounds good. So you can think this like a mock-up for our API that we will build. And then we also need an API, right? So we need a backend, which will serve as our front end. Then we will have a recipes endpoint where you can provide some query, some criteria, right? So the same search that I'm doing, you can see that we are having a REST API for it. And then as a result, you would have a response where you will get the recipe itself, right? But we need, of course, we can try, we can start building the API, but we need to consider first the communication, because you have a provider, you have a consumer, right? So they need to communicate. In this case, it's me both, so I don't need to communicate. But yeah, imagine a real-life scenario where you have like a backend developer and a front-end developer, like understanding different technologies, maybe using different frameworks and languages and so on. Maybe they even don't speak the same language, right? So we need to find a way for the communication to work. And first thing is find a common language, right? So like as a non-native English speaker, like I'm sharing some thoughts about APIs, it's the same thing. And actually, for REST APIs, already long years, we have the OpenAPI initiative, OpenAPI/Swagger. All of you familiar with it? Yeah. So most of the hands. But for the ones who are not familiar, that's the language for the REST APIs, right? So you can write it as JSON or YAML. It's self-documenting, so if you understand the language, you also know how to discover the API. And then if you don't understand the language, you have the opportunity to generate the documentation so that you have it on a more human-readable form. And you can generate code and so on. If you are not familiar, there is this website, openapi.tools, which shows all the tools that you have for to leverage the OpenAPI and do things. So I recommend you check it. And OpenAPI has a grammar, which is much easier than German grammar. Yeah, I promise, very easy to understand. So on top you have the specification version. Then you have the info section, providing the metadata information. You have server providing the connectivity information. You have the path describing the endpoints, the HTTP methods, the request response times, URL query, path parameters, and so on. And then you have the JSON schema describing the reusable objects. So now that we know we have a common language, we know how to communicate. So API provider and consumer exchange API specification. Maybe they kind of use it to generate more human-readable forms of API documentation. So now we have a framework for communicating. And then we have, because we are using the common language, we have a foundation for code generation, for documentation. There is a community behind because we have standardization. The community comes up with the tools, either open source or commercial. So yes, it makes sense, but how to get there? There are more than one ways to get there, right? So let's start observing. So our first process of development is called code first. Probably all of you know it already. So if you prefer to dive into the coding right away without thinking the communication with the consumer, this is the approach that you would probably follow. And yeah, it's quite used, or in the past it was used more, but yeah. How the process works is that the provider starts coding, implements the API changes, at some point needs to release the API, right? And once it's released, it will generate a specification. And then this specification will be used by the consumer, right? So it could be in a form of API documentation where you would discover the API and then implement the code by yourself, or it could be code generation. If you are using code generation, maybe you can speed up some things, but it's your preference, it's your taste. You could decide which way to go. And then once you consume, you can release your code, and we can conclude the integration is done. And now I would show an example for code first. Yeah, so I have my service and my client, right? So the front end and the API itself. I start, I would show, I'm using Gradle as build tool, and I would show how my project setup looks like. So I have a Java Spring Boot application. I'm using Spring Boot Starter Web to build a Spring MVC REST application, and I'm implementing my REST, controller, which would be the implementation of my API, right? So I annotated my controller with the REST controller, Spring MVC annotation. So what it does is it declares two endpoints, the post endpoints to receive new recipes, and the get endpoint to search for recipes. And then, as you can see, there are some additional annotations to kind of enrich the result specification. So far, we don't have the specification yet. So now that we have the API, we can also generate the specification. And for that, we are using a tool called SpringDoc, right? So SpringDoc will auto-configure our API specification, will create a small documentation, and we'll have, the code first achieved. Let's run our application and see how things look like. Yeah, so our application started successfully. We have our application running on a port. We can observe our generated OpenAPI specification. So it is already generated. You can see it's in JSON format, but you can fetch it in YAML format. And then you can see there is a small documentation generated, which helps you to interact with the application. One thing to consider here is that our API specification and documentation runs within our application, right? So maybe for communication, this might not be the best idea, because the specification that you see here is only the latest. So you might prefer to version your API specification. You might want to exchange your API specification as an artifact over Maven and so on. So, and then another issue could be maybe you don't have access to the server which is running that API, right? So we might prefer to generate the API specification in a way that we could use it on a build pipeline, on a CI/CD pipeline, where you could publish them, right? So let's go back to our example and see how we can do that. So for that, we have again, it's OpenAPI Gradle plugin, right? And then we can use it to generate the OpenAPI docs. And then we could see our build folder that we generated the OpenAPI specification, right? So what this did is started the application, fetched the specification from it, stopped the application. Now we have it for our CI/CD pipeline to push it as an artifact. And then, for example, I have an example where I have it available in a different form, right? So I don't need it to be as a Swagger UI. So there are many tools which generate your API specification in different forms and so on. So this was the API first. And going back to the presentation, what Code First brought to us. So we focused on coding, right? So we didn't deal with specification at all. It was automatically generated for us. We had the flexibility to change the API design before we released it. We did documentation generation, and we can generate client code. But so far, we didn't deal with the client yet because the approach we are using doesn't enable development in parallel. And also, we introduced the consumer in the communication too late. So this is one of the drawbacks of Code First. And of course, we need to add annotations in our code to make our generated documentation better. So let's see our second approach if we can improve this. So the process of API first is pretty much like the process of the new bottle caps. There is an authority which says this is the specification for the bottle caps, and then providers should build it based on this specification. And then a consumer would try to drink water, the cap would, disturb you and so on. But in the end, the idea is reducing the plastic waste. And this is API first, so as an analogy. In practice, how it works is you have a design process, right? And it could be the API provider who provides the specification, but it could also be a separate authority, right? So it depends on your organization structure. So in this case, I gave the example that API provider designs and produces the API specification. And at first place, a consumer could give the feedback, right? So there's no coding yet. And both sides, you could, for example, organize a meeting as a ceremony when both sides agree to the specification or to the changes. And once they agree, now both sides are ready to implement their APIs and of course clients. And this can happen in parallel. Yes, development in parallel is possible, but they still need to pay attention to the sequence of releasing things, right? So this is something. So always clients need to pay attention when it can deploy. Let's check an example. So first, let me make sure that I don't have any port conflict with the other. And yeah, so now I have a contract first API example. Contract first is the same thing with API first. It's just used different terminology. So we are starting now from API. So first thing, right? We have a YAML document which defines, okay, this is my OpenAPI version, this is my metadata of my application, this is my connectivity information. These are my paths, so and I'm also adding some additional description to make my generated documentation even better, right? And then many IDEs already know well about OpenAPI specification. That's why the YAML that you write on the left is rendered as a web page on the right. And any IDE, I would say, supports OpenAPI. And then you could already publish your specification as a versioned artifact. You could already publish in a different forms of documentation, so it doesn't need to run even within part of your code. And for example, in this case, I have another example where I generated some code from, I generated some documentation from this specification. And this time I'm enriching it with some markdown, with some contextual technical information. So we can see, for example, the use cases of our API, that we can get all recipes, we can get recipes by criteria and so on. Then I can see that the previous form of documentation that are generated now can be embedded and you can interact with the API. I even tried 2 different tools, and yeah, it is your preference the way how you want to exchange your documentation. Back to our example, not this one, but no, this is correct. Yeah. Now we can start building our API. So I'll show how the service looks like. So again, I have a Java Spring Boot application, so what I'm trying to build is not very different from the previous example, but this time I'm generating code. And I'm using OpenAPI Generator as a tool there, which helps for generating code. So OpenAPI Generator is a CLI-based tool, so you can run CLI to generate code. But a better approach is using a Maven or Gradle plugin, depending on your build tool, to continuously generate code, right? So in that way, the generation of the code would be hooked into your compilation, and you would make sure that the code you generated is consistent at all times. And I'll show how the configuration looks like. So this is a Gradle example, right? So I'm defining, it's highly configurable. So in this case, I'm using a Spring generator because I have a Spring application. I'm defining the input specification. In this case, I'm using the file which is on my project, but you could define your Gradle or Maven to download it from an artifact repository. This is all good. Then you could define the package where your controller should be, the base package, the model packages, and so on. And this part is the customized part for Spring Generator. So here I'm defining Spring Boot, right? Because you could also generate vanilla Spring. So in this case, you need to be specific if you want Spring Boot. Then you can generate it with a Spring Boot 3, and you can customize a couple of things. But one configuration that is really helpful is the delegate pattern. So if you enable this, it will generate the code in a way that your controller is within the generated code, and the handling of the requests will be in your implementation. So we are using the delegate pattern. So let's see how it looks like. So I have my generated classes. I have my package structure, right? The controller is here. The controller is a Spring MVC. This is generated class. Then the controller implements recipes API, where there is the declaration of our endpoints, and our get handling of our get request is delegated to our delegate class. In this case, you can see you are not enforced to implement. So let's say you might not be done with all your endpoints. So until you are not done, your API will respond with HTTP status code 501, not implemented, right? So which is very iterative and very, very natural, right? But in this case, I implemented it, and this is my implementation. So as you can see, because I'm using delegate pattern, my my API implementation is free of any Spring MVC annotations. It's free of the annotations that I will need to provide to generate the documentation because I'm using API first. So now we are done with our API. Let's start our application. I'm running my Spring Boot. And meanwhile, I can show how my client looks like. So I built my front-end UI with Spring MVC again, because that's what I know. I'm not very familiar with React and so on, but in the end, because if you are using any other tool, you can use OpenAPI Generator, which supports many tools. And if you need React, Angular, or whatever, I recommend you check all the generators of OpenAPI Generator. But in this case, yeah, I used Spring Boot again. This time I have a Java generator because the client that I will build doesn't need to be Spring-based, right? So I can generate plain Java code. The rest looks very similar. The only configurable part is the library, so you may choose your API client. Do you want it to be to use a native Java HTTP client, because there is a nice one since last versions already? Do you want to use JAX RS? Do you want to use Spring's REST template? Do you want to use Spring's web client? So there are lots of opportunities. And how my client looks like. So I have a search page, right, where I put my where I receive my input when I search for ingredients. Then when I submit, my request will end up on my controller. My controller would consume the API from the generated client, so this is generated, right? And then I will respond to the result to the Spring MVC, and then I will see a result page. So now we executed the service. We can execute the client, and we can already see that we achieved our API. Back to our browser. I have localhost 882. This is my search page. So if I don't provide any argument, then I'll simply receive all my recipes. Or if I provide something low calorie, then I will receive something lighter, right? So I asked my wife, do you like it? She said, not that much. Your application is not very smart. You should use AI, whatever. But that's maybe another talk. Yeah. So we are now done with the implementation of the API first. So let's see what it brought to us. So firstly, we communicated with the consumer pretty early, right? We got feedback. We didn't went with the cycles. Then we enabled development in parallel. We thought about documentation ahead. We were able to generate server and client code and maybe speed up our process. Then, of course, we have some disadvantages. These are like, if we are using this approach, we will have less flexibility to change the API design. So this is especially challenging when you have an experimental API that you are trying things and then you are not sure, your API keeps changing. So going through through all the ceremonies and exchanging API specification with the client and then trying to change, clients, going angry and so on. So you don't want that. Maybe at the beginning of the experimental phase of your project, you could use code first and then later on switch to the API first. And Then, but we still require integration testing to test the whole functionality. And then we have the can I deploy challenge. So development in parallel, yes, but still we need to think when to deploy. So let's see if we can make this better with our third approach. So this is consumer first. So any dog owners here? I know one, yeah. So I don't own a dog, but I looked after for a friend's dog during a weekend. I tried to walk her, and the problem is I don't walk her, she walks me, right? So consumer first is the process where actually the consumer drives the process, right? And then back to our use case. We are building a recipes API. We are building a user experience. And in our first two approaches, we kind of started the process from the provider, right? So maybe the provider is not the best, doesn't have the best expertise about user experience, right? So maybe it should start from the consumer. And we have the consumer first for that. So how it works is that we are bringing a bit of TDD to our API development process. So API consumer can implement a contract in a form of unit test and produce it as a contract. API provider will receive the contract, will run the test against the contract, and then the implementation would be as expected, right? And then you can also solve the can I deploy issue, and for that I will use Pact. So Pact is a code-first consumer contract testing tool that enables consumer-driven API development. It helps to bring TDD to your process. The way how it works is that consumer produces a Pact, provider verifies its implementation, server-client deployments are synced. Let me show how the process looks like. So again, I forgot to stop the services and I will have issues because I'm using the same ports. So this is the consumer first. So now we are starting our development from the client. We have a test. We are using a nice JUnit 5 extension from Pact. You simply annotate your contract test with Pact consumer test. You define that you are building your contract for the recipes provider. Here we define the version of the Pact. We have the pairs, so we consider that API and client are both in the picture. And then we are building interactions. So I showed 3 use cases on our generated documentation, right? So here I'm declaring these use cases. So first one is get all recipes. So for that, Pact provides me a DSL builder, which is in a form of, dear provider. Upon receiving, get all recipes to the path recipes. With the method get, you will respond with status 200, the body that matches my expected response body. I'll show in a while. Then second interaction is about getting recipes by title. So you say, dear provider, upon receiving get pumpkin recipes to the path recipes with query parameter title pumpkin to the method get, you will respond with HTTP status 200 with the body which has pumpkin in it and only that. Then third one is the same thing. If I query with the nutrition facts low calorie and high protein, I should receive a response structure which contains only low calorie and high protein. And then I have the matcher, which is a DSL, so I will not spend too much time, but you do exact match or type match. This is how it works. And then, because you have 3 interactions declared in a form of contract, you also have 3 tests for that, right? So here, Pact kind of helps me or provides me a mock server with the interactions that I implemented. And you can inject this mock server to your controller, to your internal business logic, and run your tests. Your test will be testing the business logic of your application, and it will simulate what you expect from the API. So it's a win-win, right? And here I'm injecting the mock server. I have 3 interactions, and we can already run our tests. It should be green. Yeah, and then we tested our internal business logic, plus we generated a contract. Our contract is in our build folder. It's a JSON, but the API doesn't know it yet because we need to publish. One way to publish is publishing as a Maven repository, but a better way, a Pact way, is using a middleware called Pact Broker, where you can exchange things, the contracts really nicely. So I started a Docker container which runs Pact, and we can see what's in there. It's empty. Why? Because I didn't publish. Now I can publish it, and we can see how it looks like. So I executed the test. It was green. I'm publishing it. We can go back, refresh. Now we can see that Pact has been initiated between recipes client and API. It is version aware. I'll show the use case. And now recipes API is ready to pull this Pact and test its implementation. Let's go back to our example and see how things look on the server side. Again, we are test driven, right? No, I'm not on correct application. I should be on consumer first. So how it looks like is as follows. I have a Spring Boot test which will start the application for a test during a test, and it will stop once we are done. And then I have some annotations from the Pact. I'm saying I'm the provider recipes API. And then I'm referring a Pact broker. I could refer also a Pact file, but because I'm exchanging over the broker, this is how it works. And then my test implementation is very short. So what will happen is the test will start the application. It will pull the contract. It will replay all the interactions against the application, and the API will be tested. And this is all what the client communicated in a TDD form as a contract. So let's run it. And we see it failed. It failed because it's a demo. And I want to make a point. So I have, let me show what's the failure. So it says something with the nutrition facts. We are receiving more nutrition facts than the one that we expect to be filtered. This is what I broke. Now I can fix it and rerun my test. Probably I have some cleanup issue. I will try to remove my integration, resend it, because obviously I'm having a demo issue. Okay, this looks good. We can rerun. Okay, then we can publish it again. And then I could go here. Okay, it looks good. We can check the documentation here. It looks good. And then we can try to test our service again. No, obviously I have an issue with my setup because I am testing something that yet I was supposed to add. So sorry for that, but I will skip. But the point is that after Recipes API implements after Recipes API is successful with the test, it will publish a verification and we will have a pact achieved on both sides. And then you have the possibility like marking your deployment to production as successful, and then client would ask, can I deploy, and so on. We can already do a can I deploy check, and we will see that it will fail because the Recipes API is not ready is not actually conform to the contract. So that one I can show. So I have a can I deploy check here. So the server says no, right? So this is expected because our API couldn't implement the contract as expected, right? And yeah, so this is the contract-driven form. So we can extend our pact in a way that the consumer doesn't misuse its expectations, right? For example, I had the example with I have an example where I would. So this is the test that I was going to show. So it is disabled, right? So I have a test where I expect my Recipes API to provide a high alcohol nutrition recipe. And this doesn't make sense, and this can be avoided. And let me see. I have a compilation issue. Here, yeah. Okay. So now I could use Pact to verify. I could use an additional library to validate my Pact, right? And I'm using a validator where I would read the OpenAPI specification, and my OpenAPI specification would say, I'm sorry, but high alcohol is not in my enum types. Right, so I can only provide you low calorie, high protein, and carbs. Maybe we can fix that. So we can go to our specification, add a high alcohol option here. We can commit the changes, and our test refers this specification. And we can rerun. It will probably fail internally again. I need to add an enum also inside my application, right, because I have the declaration here also, high alcohol, right? So now I will repeat my test. I'm probably it will take some time to sync itself, but I will not spend time. So I guess you get the idea, right? So you can verify things bidirectionally. So you can still set some expectation on the consumer side, but also you can control things on the API specification side, and you have best sides of both worlds, and you are still in a good way of ensuring that the interests do not conflict and so on. So back to my presentation. So what advantages did we get? So we introduced test-driven development into our API development process. Then we found a way to test consumer and provider independently, right? So here we don't need to run two applications to run a test, right? So consumer tests its implementation, publishes a contract, and then provider also runs its test against the contract. So it is independent. And then we solved the can I deploy challenge, right? So we couldn't deploy, but we know if our pact would have been achieved, we could have deployed, right? And yeah, but we also have a disadvantage. So consumer first works only when you have small number of consumers. If you have multiple consumers, each of them declaring some expectations, they will conflict, right? So it makes sense to implement it when you have a single consumer, and then later on, if you want to switch on multi-tenancy and so on, maybe it might not work anymore. So then the question is, which is the right methodology, right? So I don't have an answer, but I have some hints. So we can use code first if provider initially wants to focus on coding, experiment, and so on. Then you have the flexibility to change the design. You can use API first when you want to put the API design in the center of your process, if you want early communication with the consumer, if you want to utilize code generation both for provider and consumer. If you have a large number of consumers, you might use API first. And if you have a use case like published language, right? For example, anyone using OpenAPI, anyone using OpenAI API, right? So you can see many LLMs are using the same language. And this is the API first approach. In this case, it works when multiple APIs use the same specification. Then you could use consumer first when, let's say, you want to drive the things on consumer sides. And then if you want to test consumer and provider applications independently, if you want to sync the deployments and know when client can go, if you have small number of consumers, you could use, and then you could mix things, like we had the example where you would verify things against API specification plus the consumer. Yeah, so I'm mostly done with my presentation. This is the bonus part, but we don't have too much. If you want to apply the same three approaches for message-driven APIs, you have async API. It is inspired by OpenAPI because of the success of it and because of the community behind. It is written as JSON or YAML. It supports AMQP, HTTP, JMS, Kafka, but it's not bound to any. You can observe the tools that are provided. If you build any tool, you can submit there. Grammar is quite similar. I skipped this. This part is important. So you declare the message exchange as a channel where you say outgoing message is a ping message. So here I have a ping pong use case. And then where incoming is a pong message, so whenever I send a ping message, I expect a pong. And then you have the reusable parts. That was it. So if you scan this QR code, it will take you to a GitHub repository where you have all the examples. And I have today's presentation as a blog post, and you can reach the slides, which is accessible here. Thank you for your attention.
Can you open again the QR code, please?
Yep.
You can also paste the link in the meetup group. Let me take a look.
Yeah. So thank you. That was it. Do we have time for questions?
So, thank you very much, Enis. And are there any questions?
You were showing Pact and also the producer side.
Mm-hmm.
And I remember in the consumer side, we said something like, okay, if I put pumpkin as the search word, then I expect something with pumpkin in the results.
Mm-hmm.
But how do you make sure that on the producer side, or how does the setup work of the state of the application for the test, that there's actually data for, let's say, a pumpkin recipe? Because yeah, if I boot everything up, I would expect there's like no data, no recipes.
Yeah, good, really good question. So I guess on your implementation, some test data would do it, but on a real world, you can run your verification against production, against any URL that you give, and I guess you can do it even before going to production. So I guess you do it on an environment which is closer to production. So I would say that's the way.